welcome to a little video about Target 1D, where we're going to look at recursive and explicit formulas. First, let's take a look at the recursive. The recursive formula is a formula that takes the previous term and finds the next term. Here is the formula. Now, all of the formulas start with, let me zoom in. This formula starts with an, and that's always going to be an, and that just means any term equals an minus 1. That's just your previous term. All we need to find for this formula is the common difference. Okay, so for the next three problems, we'll be finding the common difference and plugging it into our formula. We're not going to be using the formula any other way. Well, at least for number 1. Okay, so number 1, first let's find D for common difference. To do that, we do term 2 minus term 1. So that's negative 9 minus negative 2, which is negative 7. Fantastic. Let's plug that into the formula. An equals an minus 1 plus negative 7. Let's do the same thing for B. To find the common difference, we'll do term 2 minus term 1. In this case, it's 11. And let's just plug this into our formula. An equals an minus 1 plus 11. Letter C, same idea. Let's find the common difference, D. So that's 12 minus 25, negative 13. And I'm going to plug it into the formula. An equals an minus 1 plus negative 13. Now, the use of this formula can only be applied if we have a previous term. So like if we have a second term, we can find the third. If we have the fourth, we can find the fifth. So that's what we're going to do in number 2. We're given the recursive formula, and we're given the 23rd term. I'd like to find the 24th. So an, that's the term we're finding. That's A24. So A24 equals an minus 1 is the previous term. So that's A23. Well, that looks like a 9. Let's try that again. A23. And then our common difference is plus 17. We didn't need to find it. All right. Now we need to find A24. I don't know what it is, but I do know that A23 is 947. 947 plus 17. So our 24th term is going to be 964. Let's do the same thing for B. Once again, we're given the formula, so we got the common difference. Whoops. Let's undo that. We got the common difference. We have the previous term, and we have what we're looking for. Let's write that out. A16 equals A15 minus 42. All right, so the 16th term equals negative 17 minus 42, which means the 16th term is negative 59. Next, let's look at the explicit formula. Now, the explicit formula, personally, I like it better because it works with any term at any time. So I don't need to know the previous term. I just need to know the pattern and a little bit, which is the first term. So a little bit more information. Anyways, we still start the formula with an. That's still any term equals a1, first term, plus D, common difference times n minus 1. Now, n is the number of the term. And I'll let you know what that means in a bit. But first, let's just practice writing the explicit formula. So for the explicit formula, we need our first term, and we need our common difference. Everything else stays the same until we're finding something. So let's try that for number 3a. So let's find, the first term is 9. We got that. Let's highlight it. That's our first term. Let's find our common difference. That will be 14 minus 9, so that's 5. Let's write out the formula. an equals 9, because that's our first term, plus 5, because that's our common difference, n minus 1. Let's try the same thing for letter B. First, let's find the common difference. To do that, I do 11 minus 7, so that's 4. And our first term is 7. Cool. Let's write the formula. an equals 7 plus 4 times n minus 1. One more time for letter C. To find the common difference, I do 12 minus 25. That's negative 13. The first term of this sequence is 25. I officially have all the information that I need. an equals 25 plus negative 13 times n minus 1. Now, let's actually take it and apply it. So let's find a term, just like we did in number 2, but this time we're going to do it in number 4. There. So, given the explicit formula, here it is. Let's find A22. Well, if we're looking for A22, that n right here, that's the same 22 as the A has. So this is how the formula will look. A22 equals 573 plus 17 times 22 minus 1. So those n's, those letters, are absolutely related. So what I did to solve this is I put it in exactly as I saw it. Well, I just put in this part into my calculator, and the answer that I got is 930. So the 22nd term is 930. Notice we didn't need to find the 21st term. We would have had to if we used the recursive formula, but not for the explicit. That's why I like it better. All right, letter B. This time we're looking for the 12th term. So, A sub 12 equals 324 minus 11 times 12 minus 1. Once again, I put exactly this into my calculator. And what did I get? I got 203. Beautiful. Now let's actually apply this. Where does this matter? Well, one thing that I thought to use for our examples in class is growing plants. So for example, number 5. When first purchased, a tree sapling measures 15 centimeters tall, and then it grows 4 centimeters in size every month. So let's represent it in the table. The first month is 15 centimeters. That's month 1. Then we grow 4. That's plus 4. 19. Plus 4. 23. And we're going to continue adding 4. 27 plus 4. 31. Letter B says, write the explicit or recursive. We're going to do both. Explicit. That's my favorite. Explicit is an equals a1 plus d times n minus 1. A1 is our first term, so 15. plus d, which is our common difference. We were growing 4, n minus 1. As for the recursive, it does start out with an, but it's an minus 1 plus d. So this would just look like an minus 1 plus 4. Now the reason I prefer the explicit is for this next question. Predict the height of the sapling after 8 months. Well, I would have to keep counting by 4s for the table or for the recursive, or I can just use my explicit. Since I'm looking for 8 months, that's what I'm plugging in for n. So I'm looking for 8 sub n equals 15 plus 4, 8 minus 1. Again, I prefer the explicit. I think it's faster. I put that first part into my calculator, and I got that after 8 months, my tree sapling is going to be 43 centimeters tall. Okay. If you have any questions for me, please let me know. Otherwise, have a wonderful rest of whatever day it is for you. Bye!